course title is known as Computer Technology. Our course code is CTE 431 week 2. Application of multiplexer. So let's look at this. Multiplexer are used in various fields where multiple data need to be transmitted using a single line. So regards to this, as we said earlier, multiplexer accepts multiple input and only gives out one output. So with this, following are some examples of multiplexers. So one, we have communication system. So regards to the communication system, is a process whereby someone will be able to publish news so that multiple audience will be able to have access to it, like radio station or television channel and so on. So telephone network. So this telephone network will allow individual to communicate with each other in different destination. Then we have computer memory. So regards to the computer memory, it will be able to store vital data and information that is needed and also send to the particular person they intended to send the message to. So we have digital electrons. So those digital electrons are devices that will enable us to have a simultaneous communication between individuals. We are still on applications of multiplexer. So communication system. In multiplexer, communication system is a set of systems that enable communication transmission system relay in a tribunary station. This tribunary station refers to the workstation of radios that will be able to publish data and information or vital information so that it can be able to cover large audience. And communication network, the efficiency and the communication system can be increased considerably using multiplexer, because with the help of multiplexer they will be able to increase the ability and capacity of those communication channel, since multiplexer accepts multiple input and gives out one output. So it has the capacity to accumulate multiple data at once and provide them in serial form. So multiplexer allow the process of transmitting different type of data such as audio, video at the same time using a single transmission line. So regards to this, you'll be able to work with multiplexer in terms of video or audio. So let's look at telephone network. So in telephone network, multiple audio signals are integrated on a single line for transmission. So since we communicate with phone, you see that you'll be able to talk many things, but it can only go in one channel, which is the cell phone. With the help of multiplexer, you will be able to interact and pass your message to individual in different destination. So let's look at computer memory. So regards to the computer memory, multiplexer audio signal can be isolated. So you can use computer memory of multiplexer to send audio signals or videos to individual, and it will definitely go to the person you intended to send the message to, which is the recipient, which is the receiver. So let's look at the digital electronics. Multiplexer are used to create complex digital circuits such as arithmetic and logic unit. So the function of ALU, which is known as arithmetic and logic unit, provide a means of calculation for mathematical aspect in computing. Let's look at this, the multiplexer. So once we said the multiplexer, we are referring to a circuit that is capable of accepting only one input and gives out multiple output. So a demultiplexer is a circuit with one input and many output. By applying control lines, we can steer many input and many output. Types of demultiplexer. So here are some types of demultiplexer. We have 1 to 2 demultiplexer, 1 to 4 demultiplexer, 1 to 8 demultiplexer, 1 to 16 demultiplexer. So let's look at the first one. We are to create a two controls lines which are known as A and B, as we explained from the previous class. So the A should represent 0 0, then the B should represent 0 1, then the output Y. Regard to the second one, which is 1 to 4 multiplexer, the A should represent 0 0 1 1, then the B should represent 0 1 0 1. Also applicable to the 1 to 8 multiplexer, demultiplexer, we are to provide 0 0 1 1 0 0 1 1. Then we can also go to the, that's for B. Then for the A, we are to input 0 0 1 1 0 0 1 1. So that's all we have for the examples of those multiplexer. Illustrate the general idea of demultiplexer with one input signal, M control signals, and M output. So let's look at this. So the M control lines, which is located at the first diagram of this demultiplexer, right? So this M controls lines refers to the input lines that are not yet selected. So the input signal, which show us 1, right? That's the one we have selected from the M controls lines. So those M controls lines will not be able to have any function since they have not selected any of them. So we have to take one of them which is visible into the input, since it is a demultiplexer circuit. So here is the demultiplexer circuit which accepts only one input and gives out multiple output. So let's take a look of this. So this is the one input signal which was selected from the control lines. Then here is the M output signals, which is the output, which are 4 also. We have 1 2 3 4. So the multiplexer accepts one input and gives out multiple output. Let's take a look of this. Understanding 1 to 4 demultiplexer, as we said earlier, since we said that the multiplexer has one input line and multiple output lines. So let's look at this. So the input line is represented by D, which is the data, as we can see the line. So here is our controls lines, which are known as A and B. So those are the controls lines that control the affair of the demultiplexer. We are the one that connected the input and output terminals. So let's look at those AND gates. We have 4 AND gates. So what we are to do here, we are to draw the first line to the first control line, which is known as A. So the second one should go to the B, then the third one should go to the output line, the input line, which is the data, as we can see in the diagram. The first line goes to A, the second goes to B, then the third one goes to the data line, which is the line. Then here is the second one. Our first line on the second AND gate goes to the first terminal, so the second line of the AND gate goes to the second terminal, which is B. Then the output, which is the data, which is the last line on the AND gate, goes to the data line, which is the input line. So here is our output, which are known as Y0, Y1, Y2, Y3. So as we said earlier, 4 to 1 multiplexer. Here is the truth table of the multiplexer we are talking about, that our input data signals, which are known as A and B. So the A is represented as 0 0 1 1, then the B is represented as 0 1 0 1. So here is our output, Y0, Y1, Y2, Y3. So 1 to 4 demultiplexer circuit. let's take a look. The input bit is labeled as data, as we said earlier, as we see on the previous slide, that the data type presented the input lines. So this data bit is transmitted to the data bit of the output lines. So all output lines are connected to this one line, which is the data line, which is the input line. This depends on the value of AB, which we know that this AB is the control lines whereby all AND gates are connected to them. Then the outputs are only connected to the data line, which are the input. So now let's say that when AB is equals to 0, 1, the upper second AND gate is enabled. So what the expression we are to understand here is that on that previous slide in our truth table, the first number we have 0, 0, then the second one is 0, 1, then the third one is 1, 0, then the fourth one is 1, 1. So we are talking of the second AND gate, which is known as 0, 1. Since the upper second AND gate is enabled while all other AND gates are disabled, so regards to this expression is that this 0, 1, which is the second AND gate, it is the only AND gate that is enabled or is recommended. So others are not recommended. Then our given, therefore only data bit D is transmitted to the output given. Y1 is equals to data. So which of the one should represent Y1, which is 0, 1, since we said that the output should be Y0, Y1, and Y1 is represented with 0, 0, which is the second AND gate. So let's take a look. If the control input is changed to AB, then which is equals to 1, 0, then we should come to our table and see that which of the one is 1, 0. Then we will now realize that is the third one. The third one should be the 1, 0. Then we will now say that all the gates are disabled except the third AND gate from the top. Then D is transmitted only to the Y2 output bit. So if you look at this now, the third gate represented by Y0. So that's how the expression goes. Then this is transmitted only to the Y2 output bit, 4 control bits and 16 output bit. So examples of 1 to 16 demultiplexer. Let's take a look. We have IC 74154. It has 1 input bit, 4 control bits and 16 output bits. It is a printed circuit board which is embedded with multiple features, and those features has their specific functions.